All right. Good afternoon, everybody. Thank you for coming to our talk. My name is Stephen Yu. I'm a solutions architect here at Databricks, focused on the streaming efforts for our customer-facing field teams. I'm joined today by our awesome product manager for streaming, Ray Zhu, and VP of ML at Upwork, Erica Lee. Today, we're going to be talking about streaming on the Lakehouse. So I'll go ahead and kick us off. I'll talk about a little bit about how we think about streaming at Databricks. Introduce or overview structured streaming, and then Ray is going to walk through how we think about streaming in the Lakehouse, talk about some design patterns. Then finally, Erica will walk us through a really cool machine learning streaming use case at Upwork. All right, this is our safe harbor statement. Please give that a quick read, and then we'll go ahead and get started. All right, so let's start by defining what streaming data is. Streaming data can be defined by having like two key characteristics. One, it has to be continuously generated, and two, it's unbounded. So if we take a look at a couple of examples, we have things that are traditionally, that you think of as traditional streaming data sources, like click streams and IoT data. But you also have things like database change feeds and application logs. And if you think about it, the vast majority of the data that we generate in the world fits this definition of being continuously generated and unbounded. So how should we think about processing this data? Well, traditionally speaking, like for batch, we did this one-off bounded processing where you would take some data, you would land it in a storage layer somewhere and basically create this artificial boundary. Then you would take that data and then you would process it. This is a two-step thing. But following our definition of streaming data, stream processing is also continuous and unbounded. So as data gets generated at the source, you go ahead and process it. So what are some of the technical advantages of this approach? Well, because we don't have this artificial boundary around unbounded data, it's much more intuitive to think about. And when you're stream processing, you're generally working with smaller amounts of data per processing run, so the processing latency is naturally lower. Then you have this concept of checkpointing. Most stream processing engines have this thing that keeps track of all the data that you process, data that has not yet been processed, enabling fault tolerance. And then finally, because stream processing is continuous, you have this more consistent utilization of compute. So basically what you're doing is taking a large chunk of data and you're spreading it out over a longer period of time, which leads to better scalability. Then from the business perspective, let's take a look at BI and SQL analytics, for example. Stream processing enables you to have faster insights, which in turn leads to quicker and better business decisions. And then on the data engineering front, the sooner you have these clean data sets available for your downstream data consumers, the more business use cases and applications get unlocked. From a data science and machine learning perspective, streaming enables things like streaming inference, streaming feature computation, which Erica is actually going to be talking about in just a little bit. And then finally, from like a really cool, innovative, cutting edge application perspective, we have event-driven applications, which enable things like real-time fraud detection, customized ads, or things like dynamic pricing during a live user session. So I'm sure a lot of you, aren't coming to this talk today without ever having heard of streaming. At this conference, I've talked to a number of people about what their thoughts on streaming were. I've talked to many customers over the years at Databricks, and we've distilled sort of these common misconceptions down into two key things. So misconception number one, you may have heard this before, like stream processing is for low latency use cases only. That's actually patently false. So let's think about this. The definition of streaming data is continuous, and it's unbounded. Nowhere in that definition does it say it also has to be low latency. As a matter of fact, At Databricks, we have a number of customers utilizing this thing called trigger once, or trigger available now, which basically allows you to take what was traditionally a batch processing job and leverage the stream processing framework that enables things like fault tolerance, resilience, exactly once. So now you can leverage the framework to keep track of what data you've processed, what data hasn't been processed. And then you can actually go as far as saying, OK, well, if that means that stream processing is not just for low latency use cases and can be used for a variety of things, real-time, near real-time, batch, you can actually think about batch as a special case or a special type of streaming. All right, so we've established there's a range of latencies, but that leads us to the next misconception. I thought faster was always better. And again, like this isn't always the case. It's a bit of a trade-off, right? So low latency means you have smaller processing windows, which leads to higher processing costs, right? And that also translates to less accurate results if you think about situations like accounting for late data. So there's a bit of this trade-off triangle here. It depends on what your workloads are. You just have to make sure that you're making the right trade-off for the right workloads. All right, so let's move on and talk about structured streaming, which is one of the most popular stream processing engines today. So structured streaming was created in 2016 with the goal that streaming should be easy, right? So it was built on top of Spark SQL APIs. And actually, one of the creators of structured streaming said, streaming is actually the easiest when you don't have to think about streaming at all. So let's take a quick look at what this means. We'll break down the components of a streaming query in structured streaming. So you have this concept of a data source. You're reading data from some sort of a replayable thing like a message bus, or maybe even object stores. You're taking that data and then you're transforming it using the same data frame APIs that you would use in batch world. You then write this data to some kind of a sink. That could be either a message bus, could be an object store. And then you wrap this all up in this concept of a trigger execution. So everything is being executed either immediately, every 30 seconds, every hour, just once until the next time it runs. And of course, this wouldn't be a summit talk without actually going through some code. So let's take a look at what that actually looks like. And so when you create a stream, all you have to do is change what was your traditionally a batch API call to spark.read as spark.readstream. Your transformation, again, is your standard batch data frame transformation. And again, all we've done here is change the dataframe.write call to dataframe.writeStream. And then we pass in some configuration information that defines like how frequently we want this thing to run. So zooming out a little bit, and we've touched on this now, I think, quite a bit. One of the biggest benefits of structured streaming is that it unifies batch and streaming APIs. Now, why is this important? Well, now this means that you are now maintaining a single code base. You don't have to manage multiple complex distributed systems in order to get the benefits of batch and streaming. From a throughput perspective, you may have seen in Karthik's keynote yesterday that some of the largest workloads that we have at Databricks are processing trillions of events per day. This translates to tens of millions of events per second. We have exactly once semantics. So this is enabled by a feature called checkpointing. Basically, you don't have to think about what you've processed, where you left off. You don't have to think about, oh, OK, my job failed. What should I do? As long as you have a replayable source and an idempotent sink, you have exactly once. And then finally, from a connector ecosystem perspective, we have support for streaming message buses like Kafka, all flavors of Kafka, Kinesis. And we even have support for object stores using a really scalable streaming data source called Autoloader. And likewise, these also translate as data sinks. And as a part of Project Lightspeed, we're also expanding this connector ecosystem. So I'm going to bring Ray onto the stage to sort of talk about how this all ties into the Lakehouse paradigm. Ray?
Awesome. Thank you, Stephen. Hey guys, super excited to be here to talk to you a little bit about streaming on the Lakehouse. As Stephen mentioned, structured streaming is sort of the heart of all the streaming capabilities we've built into the Lakehouse platform. But we've got more than just the engine, so we'd love to share that with you guys. And before I get started, I just want to do a quick recap of what a Lakehouse is. So the idea is fairly straightforward. So historically, people have been using two different data platforms, one for running data warehousing and BI workloads, and the other for machine learning and AI workloads. And there are a few problems with that approach. Number one, you gotta have to store your data in two different siloed places. Not only it incurs extra cost, but also it's very hard to maintain the consistency of the data between these two different platforms. Number two, because of these two different platforms, you're gonna have incompatible security and governance model. And number three, because your different teams, different personas are working on different workloads out of two different platforms, it's very hard for them to get them to collaborate with each other. And the Lakehouse is basically a modern architecture that's trying to solve these three problems by providing a unified platform to store all of your data in a single place with a unified security and governance model, and also allows you to run all sorts of workloads on top of it. And this is Databricks Lakehouse Platform. It's simple. It unifies all of different workloads from BI, data warehousing, SQL query, machine learning, data science, and streaming, all from a single platform. It's open. It's built on top of open source and open standards. And number three, it's multi-cloud. So for those of you who want to have the freedom to work with any cloud providers you wish, or even architect a multi-cloud architecture, we've got that covered for you. And for streaming on the Lakehouse, it sort of embraces the same unification idea of the Lakehouse to make things simple. And we want the Lakehouse to be a one-stop shop for all of your streaming workloads, from ingestion to ETL to event processing, event-driven applications, and machine learning inference. So you can ingest all sorts of data, streaming data source, from change data feeds to IoT data, application logs into the Delta Lakehouse. And on the other hand, you can build different type of applications and pipelines for things like near real-time dashboard, for things like fraud detection, dynamic pricing, dynamic advertising, all kinds of real-time and non-real-time applications. And for those of you who might have heard Karthik talk in the keynote, we've seen tremendous usage growth of streaming workloads on the Databricks Lakehouse over the past 2 to 3 years. And we think there are a few reasons of why that is happening. And number one, Stephen touched upon, we use a unified batch and streaming API approach. And not only the structured streaming engine has this unified API, all of these other streaming capabilities we built on top of it, things like autoloader, things like Delta Live Table, all follow the same design pattern, so that as a user, you don't have to learn any new programming model, a new API, or maintain two different separate stacks, one for batch and one for streaming. And number two, streaming really is beneficiary to a lot of different workloads and users. You know, for business analysts, for data scientists, software developers, machine learning scientists. But all of these different users, they all want to work with streaming data from their favorite tools. Could be a notebook, could be an IDE, could be a BI tool. And the Databricks Lakehouse provides or integrates with a diverse set of these different tools. So for all these different user personas within the organization, when they interact with streaming data, when they want to take advantage of streaming data, they can work out of their favorite tools without making any changes. And number three, cost structure. Stephen sort of mentioned on that. There's a trade-off between latency and cost structure. And a lot of the time, depending on your use case and workload, you want to make that trade-off differently. For certain workload, you want to err on the side of low latency. For certain workload, you want to err on the side of low cost. So for Databricks, it allows you to flexibly configure this particular trade-off for every single one of your workloads, so that overall, you can make the right performance cost trade-off for all of your streaming workloads. And last but not the least, building a streaming pipeline or streaming application requires more than a a processing engine. You gotta have a long-term storage system that supports streaming semantics. You gotta have to integrate with upstream message buses to ingest the data before you can process them. And the thing with Databricks Lakehouse is we provide all of these things you need to build an application or pipeline so that you don't need to spend the time and effort to stitch different technology stacks together in order to build an application or pipeline. Next, I want to talk about some of the streaming workloads and design patterns we've seen our customers doing on the Lakehouse platform. Let's start with ingestion. So there are two categories of different storage systems that capture streaming data. One category is what we call message bus, things like Apache Kafka, Pulsar, Kinesis, PubSub, Azure Event Hub. These are systems designed for high-frequency reading and writing of very small payloads, like a few kilobytes or even a few bytes. On the other hand, you have these object storage systems like Amazon S3, AWS, Google Cloud Storage. These are low-cost storage systems designed for larger payloads, but at a much lower read and write frequency. And for Databricks Lakehouse, we provide out-of-box integrations with all of these different storage systems. So it's just a matter of a few lines of code to ingest data from these different systems into the Lakehouse in a streaming manner. And now you've got your data ingested into the Lakehouse. You probably need to do some transformation, you probably need to do some filtering and cleaning up, and probably also do some aggregation before it's going to serve the downstream BI and data science tools. And here we have two options for you, Delta Live Table and Structured Streaming Engine. And this is how you should look at these two different options. Delta Live Table is our fully managed ETL product on the Databricks Lakehouse. It supports both batch and streaming, really focused on ease of use. It takes care of a lot of the heavy liftings as you're building streaming ETL pipeline, things like pipeline orchestration, failure recovery, scaling the infrastructure, monitor and manage data quality. Delta Live Table takes care of these things so that you can focus on your transformation logic. And it's the preferred way of doing streaming ETL on the Lakehouse platform. So if you are considering any new streaming ETL workloads, Delta Live Table is where you want to look at. On the other hand, structured streaming, it's the same Spark structured streaming API you've been using. And it gives you the full flexibility to roll your own streaming ETL pipelines. We have the structured streaming engine, give you the out-of-box integration through the Delta connector, and on top, you can use our orchestration product from Databricks called Workflow. It gives you the flexibility to roll your own data pipelines for streaming ETL. And if you're considering migrating an existing structured streaming workload onto Databricks, that's a no-brainer path to go, because that you require the least amount of effort to move that workload onto Databricks. Next, I want to talk a little bit about event processing. Now, this graph might look a little like streaming ETL. There's just one key difference. For streaming ETL, we're referring to when you're doing the transformation and ETL inside the Delta Lake, which is backed up by the object storage system. In this particular graph, everything happens in the message bus, like Apache Kafka. If you recall, these are the systems designed for very small payload, high-frequency read and write, which really gives you the minimum possible latency. So as customers adopt to more and more real-time applications, this is a pattern we've seen where you can use structured streaming engine and in the near future, Delta Live Table to do the transformation between two different message buses without touching the object storage system, which really minimizes the latency. And once the data has been processed, then you can do real-time actions, as Steven mentioned, things like fraud detection, dynamic pricing. Give you an example, in the financial sector, we have customers ingesting financial transaction data from their servers into an Apache Kafka topic. Then from there, they're using structured streaming engine to process data and detect a particular fraudulent pattern and behavior. Once a particular fraudulent behavior has been detected, from the structured streaming application, they're making external API calls to their backend server to suspend a particular account. And all of these things happening with the end-to-end latency of a matter of a few seconds. And you can do all of these things on the Databricks Lakehouse platform. And lastly, I want to talk about machine learning inference. So traditionally, you can do batch inference on a pile of data. but it's very easy to convert that into a streaming inference pipeline. It gives you all the benefit of streaming, things like scalability, fault tolerance, and it gives you inference results much sooner. So with that, I would love to welcome Erica to the stage to talk to you about how Upwork is using streaming and machine learning pipelines. Erica.
Thanks. Hello, San Francisco. It's so good to be back. Only in SF will we be driving up the 5 seeing a billboard that says SSOT for a single source of truth data. So I love this city. Let me find, is this the clicker? I didn't have a chance to run it. No, just tap it, okay. Before I kick off, my name is Erica, and I am our Vice President of Machine Learning for Upwork. My main role is setting the vision and strategy for our infrastructure and application teams. And I'm here representing 2 of my main leaders in my team. One, Alexi, who's not allowed to be, who's not here. He leads one of our infrastructure teams. And Legu, who is sitting right here. Hopefully we'll have her speak in one of our future talks. She is our Machine Learning Engineering Director for Search and Discovery. So a little bit about Upwork if you're unfamiliar with who we are. Upwork is known as the world's work marketplace. So essentially, we help large companies staff freelance talent worldwide. About 30% of customers in the Fortune 100 work with us, including Databricks as well. And we also serve a lot of enterprise customers. We mostly staff software engineering, kind of development roles, customer service, as well as operations. And mostly in machine learning, our main vision is really about how we use automation to scale a lot of our services internally. So a couple of them include search. So if a user has a query, we're able to use query understanding to find their intent and help them find something in our ranking algorithms. 2, discovery. So this is if a user doesn't know what they're looking for, and we show them recommendations, kind of pushing things to them inbound. Trust and safety, that team is led by Alex, who's here actually, senior manager in our team. That's really about finding a scam, so essentially automating fraud detection with job posts, as well as more upstream with different kind of client accounts, and really about tracking bad actors. Marketing as well as growth, so a lot of stuff around customer lifetime value and understanding business health metrics to help our business scale. And yeah, I'm really going to walk to you basically 2 main things. One's kind of our system design about how we use the Spark structured streaming engine, as well as some of the, oops, sorry, I've not spoken live in a couple of years, as well as a couple of the benefits that we use with some opportunities that we're also hiring for. So a little bit about the Spark structured streaming engine. We pull a lot of our data from different kind of upstream microservices. The 2 main data sources that we pull for search are either business event streams, so this can be business data like different, I wish I had my clicker, but job posts, application, kind of all the stuff that comes in. And the second one is UI events. This is more about user data, such as clicks, impressions, etc. And we both use the Amazon Kinesis data streams. And the cool part about using the Databricks platform is we actually can combine that data so we can see a more holistic view about it, so we can see different types of meaning and insights, such as what's the job post impression per sliding window. So how many job views did it get in 5, 10, etc. minutes? And that helps our machine learning engineering team really analyze that and provide recommendations. So after we combine those data sources, we start serving it so they can actually go to our downstream consumers and actually hit our customers. So they mentioned right beforehand that one of the benefits is a unified API for both batch and streaming, and we utilize that so we have kind of one tool that allows us to do multi-different functions. Here we use the Delta table, and for Spark Batch, one of our use cases is called client hiring state. We use the XGBoost model. In fact, all of our examples are XGBoost just for simplicity, but I swear we do more than that at our company. But this really tells if a client is hiring or not, so we're able to tell kind of how likely they are to hire. So that's more batch because it's not as important, that's in real time. And the second one, use case, is really about Spark Streaming, which is why you're here for our talk. We use another XGBoost model called BestMatch, which I'll show you in the next slide. And BestMatch really is a recommendation ranking algorithm that shows you like what's the best match talent for the job that you're hiring for. We kind of combine those in a proprietary messaging queue that we've developed internally and then serve them downstream to our microservice team. So a lot of the search front-end web development teams that serve them to the customer. We also use like different infrastructure and tools in-house. We also use Amazon DynamoDB. We have our own internal live feature store, as well as using the SageMaker platform with the containerization orchestration service as well for another service. So I'm trying to show you these as like a comparison so you can see we use it for both batch and streaming through Databricks, but we also use it for streaming through SageMaker. But the whole point for us is really about how do we deliver technology and data to our customers so they can get the best outcomes. So, oh, we are right on time. Okay, so BestMatch. So this is a little bit about what our product looks like. Here's our website, and it kind of shows you just essentially in real time what is the best talent for your job if you are doing a query. And here's kind of a close-up. The main takeaway here in terms of our customer impact is about over 50% of our job posts get about 25 or more bids, which is people applying for them within the first day. And that has steadily been increasing over time as well. So we're really excited to actually be launching new search and discovery models later this year. A couple of the benefits of the Databricks platform. One I mentioned earlier was the batch and streaming side. So it's a unified API that allows us to do both, as well as they have an interactive collaborative notebook that allows us to save developer time. So when I joined, we've been hiring one person maybe every week or two. So kind of onboarding people takes a lot of time. So being able to do cross-training and more in a simple tool has been really helpful as we scale our team internally. And if you're interested, we are actually hiring. We're a fully remote, diverse company. Our headquarters is in San Francisco, but I'm based in Seattle. A couple of people are based in elsewhere. We're hiring the management side, machine learning engineering managers for different applications, search, fraud, as well as infrastructure. And we're hiring some individual contributors as well on the ML ops side, which is essentially kind of helping in the combination of ML engineering, ML infrastructure, as well as MLE, which is kind of the traditional, what people think as both a data scientist and someone that actually productionalizes live models. So it's been great to have Upwork present here, and thank you so much to the Databricks team. And please contact our recruiter, Aaron White, if you're interested, or find me, La, Yanni, Alex, or anybody else. Thanks so much.
All right, I'm live. All right, cool. So I just came back up here to say thank you for coming. For those of you online, thank you for viewing. We'll be around to answer some questions. So thank you again.